In this video, we are going to be doing transformations and graphing from y equals ax minus h squared plus k, which is called our standard form or the vertex form. So we have the standard form / vertex form, and we also have the general form, and we're going to get into that in later videos. But in this video, we want to talk about the vertex form, and we are transforming graphs. So we're going to take equations in this form and we're going to graph them. So it's really important that we know what both forms are and how to graph them. So let's get straight into an example. Okay, so here we have an example. We have y equals 2 in bracket x minus 1 close bracket squared minus 3. Now this form is in the vertex form because remember our vertex form looks like this, equals okay, so again, looks very similar. General form looks more so like ax squared plus bx plus c. So there's a difference. You will be able to tell the difference when you look at a question to determine what form it's in. We also have like our line, which is y equals mx plus b. So there are different ways, but I think we will get there. Okay, so we have y equals 2 x minus 1 squared minus 3. The first step is to identify the vertex. The vertex in this equation, or our vertex, is always our h and our k. So our h and our k over here. So in this case, we have -1 and -3. But, and this is really important, like as you progress, you're going to notice that this, what I'm about to say, is important. You have to take the opposite sign on your h. So in this case, our h is a -1. We're going to take a +1 instead. We're not going to use the -1. So when we're bringing out our vertex is going to be 1 and -3. Not -1 and -3. We take out the opposite sign. And that the same thing goes for when we're going from a graph back to an equation. You're going to take the opposite sign of your vertex. It's really important because we're going to get into transformations, which are, deeper changing, stretching, and, reflecting your graph. And knowing that you're going to take the opposite of h is going to be really important. So you take the opposite, and that's going to be your vertex. You plot that point on your graph, right? So we have our vertex is 1 minus 3, so we're going to have a graph here. Pretty simple graph. Let's plot that point, 1 and -3. So we have a 1, -3 right about here. Okay, so we'll plot that point. So the next step is to choose a value of x on one side of the vertex, plug it into the function, and solve for y. Wow, that seems like, what in the world does that mean? But it's simply, we're just going to pick any point on the other one side of the vertex, plug it in, and solve for y. So we are going to let x equal 0. And so wherever we see 0, we're going to plug it into our equation. Wherever we see x, we're going to plug in 0 in our equation. So y is equals to 2, 0 minus 1 squared minus 3. Y will be equal to 2 multiply 1 minus 3, which is equal to -1. So y is going to be equal to -1 when x is equal to 0. So our point here is 0, -1. So we can look for that on our graph and plot that point. So we had a 1 and a -3. And now we have a 0 and a -1. So 0 on x and -1 on y. Then we can do, let x equal something else. We can let x equals 1, for instance. Let's do that. Color. Again, we're going to have y equal to 1 subtract 1 squared minus 3. Y will be equal to 2, 0 minus 3. Y will be equal to negative 3. Now, I could have saved myself steps. I didn't need to do let x equal negative 1 because we already know what y would be when x is going to equal to negative 1. And y would be negative 3 up here, our vertex. So x is negative 1, y is equal to 3. So I did not need to do this step, right? Not necessary. So you can skip that step. We can go to let x equal negative 1, right? So it's going to be y equals 2, negative 1, negative 1, minus 3 will be equal to y equals 2, negative squared, pardon me. Y would be equal to 4 minus 3. Y will be equal to 8 minus 3. So y would be equal to 5. So when x is equal to negative 1, y is equal to 5. So negative 1, 5. Whoa, that is very, very wonky. Okay, so now you have enough points. Like I said, you minimum of 5 points. You need a minimum of 5 points, and it also depends on your instructor or your teacher. So confirm with them what they want. But for me, I find that you need a minimum of 5 points on your graph. Now I have 3 points on the left side of my graph. So I need at least 2 more points on the right side of my graph. So the best way to do this, instead of going to say, oh, okay, so let's do let x equals positive 2 or, positive 3, you can just mirror your graph. So here where we have here x is equal to 0 and a negative 1 right here, we can mirror that to the other side. So, and to mirror, I think there's also a tendency to make a mistake, but to mirror it, your y is going to stay the same, but your x is going to be different because we want another point somewhere over here. So our y is going to stay the same, so our y is going to remain at a negative 1, but when we mirror it, it's going to be a 2 negative 1, so our point is going to be right here. And the reason why I know that that's correct, when you go to fold this graph like if you go to fold it on the axis of symmetry, you're going to find that those 2 points are going to touch each other. Again, usually another way to know is the space in between them are going to be the same. So we have here, ignore this, like an imaginary line. Here we have a space of 1 to that line, and we have another space of 1 to that line. If you want to guess what the imaginary, the flip of this top one, which is a negative 1 and a 5. Again, the 5 is going to stay the same, but then the negative 1 is going to move. So we're going to see how many, loops is it going to take for us to get to the middle point. So we're going to count that same loop. So we have here negative 1 to 0 is 1 loop. Then then 0 to 1 is another loop. So we have 2 loops. So we have 2 spaces in between. So then we're going to count 2 more loops. So we're going to have 1 to 2 is 1 and 2 to 3 is the other one. So that would be our next point, which means it's a 3 and a 5. So now we have a great parabola. Not so neat, but pretty great. You're going to try to connect your dots. Lots harder to do on an iPad. Okay, so that is the best trick I can give you, is you find your middle point, your axis of symmetry, where your vertex is, draw a line, and you're going to count how many spaces are in between your first point to that line, and you're going to try and mirror that to the other side. So you're going to have the exact same amount of spaces from the line to your next point to find your point. So that is how you mirror your graph. And that is basically it. That is basically how you plot your points. So you make sure you add your arrows, you connect your points, you label, and this is pretty much it. Again, just to go over what we did, the first step is to find your vertex. I feel like you can't really do anything until you know where your vertex is at. And you just take out your H and your X. Your H and your X values right here. Your H and your K, your H and your K values. And take the opposite sign on your H. You have to remember to take the opposite sign on your H. So I have a -1 over here. It turns into a +1, -3. You plot that, and then on each side, just pick a random number. Let X equals 0, 1, 2, 3, and find Y, and then you just keep plotting that, and then you mirror your point. And that's pretty much it. I hope you guys learned something from this video. I will see you guys in the next video.